Hi, it's Gadget UK here again. This is a board that was donated from Tom over on AEB. EAB? Yeah, English Amiga board I think it is. So yeah, this is one that he'd had a quick look at, and you can see someone's been tinkering on this. Massive amount of hot air, look at this, it's almost incinerated there. So yeah, some damage around there. The socket is kind of melted the plastic. But I'm not so sure that is the issue. Well, obviously, you know, that's going to have a bearing, but I don't think that's the fault. I think the original fault with this, from what I understand, is it's outputting garbage. It's not really displaying properly. I think he was saying if you connect up diagram, you can kind of get some text there, but it's kind of garbaged again. But my first thoughts are, you can see I've removed the CPU. Can you see down here? Corrosion. So, I mean, you know, it's lightly corroded this. Someone has in the past removed the battery and stuck a CR2032 on here, but the pins are all green, so I think the issue might just be corrosion. Actually, that might be what's wrong with this. So I'm going to start off just with some vinegar and clean up this area, you know, to the toothbrush as well. We'll get the CPU back in, we'll go and try it. You know, I'm reluctant to try it with this like that, but I mean, I can't do much about this. I can clean this up a little bit. You know, there's a bit of a black and charred PCB there. I can fix some of the traces and things if any of those are broken. But this one could be a challenge. It could be a challenge. Yeah, so I'm surprised that when you get boards like this that nobody cleans up. You know, and you can't just clean up. You actually need to remove components and sockets and things. I mean, there's a chance this had been cleaned up when it first leaked. The big problem with this is that if you don't clean off all of the alkaline there from all around wherever it's leaked, it kind of just spreads, you know, it starts again. You know, this bit here, if you don't deal with this and then you just clean up around the socket and stuff, give it a year or two, you'll find some of the pins go green again. It's amazing how long lasting the effect is. You know, you can think it's stopped eating its way into things, but actually it continues. I guess with temperature changes and humidity and stuff, it kind of starts up again. So we'll just get some white vinegar into a little cap here, and toothbrush, and just do a little bit of this here. I mean, they're not too bad, it is quite light. You could argue it's quite superficial on this one, so maybe this has got nothing to do with the faults, but I'd rather just rule it out anyway. And I've got some IP onto a toothbrush afterwards, and just wipe up with cotton swabs. I might get this socket off later if I think we need to, but you never know, the corrosion might not be the issue. I mean, to be fair, after cleaning that up now, it's come out pretty well, actually. I'm not seeing very much in the way of green. The one thing I would point out, this pin here, can you see, it's like super black. Can you see how it stands out compared to the others? And it's the same on the other side. Both sides of that's totally corroded, that pin. So this might have been his issue, actually. There might be nothing wrong with the board, or there might have originally been nothing wrong with it, I don't know, other than that charred area. Well, this is super interesting actually. You can see we've got a display, it's booting there. There are no issues at all with the boot, but can you see, it's like, let me move the camera, hang on. Can you see it's like the contrast or something, it's like brightness, it's not very bright at all. The image is kind of like a little bit distorted as well, like maybe there's a problem with one of the sinks there. So yeah, that is super interesting. So what could cause that? Well, I'm thinking video output stage, I'm thinking hybrid actually, and things that feed into the hybrid. So, you know, you've got these chips here, those of the DAC, but would that result in why would it be just, the colours look right, so it's not like one colour's not right, it's like a brightness contrast thing. Denise, might just rule Denise out, swap Denise, but I don't think so. I don't know, this is very interesting. I'm amazed it's working though, with those chips looking like they do, you know, in the area there, in between the CPU slot and the Zorro slots. But this is not, I don't think this is a corrosion issue actually. So, despite the fact there was a little bit of great greenness sort of around there, and that pin was looking a bit dirty on the CPU there, that is not the issue. Oh, it's just frozen, just noticed. So there is some sort of instability here, because, and that could have been me just putting a bit of pressure on the chips and things there, but it did freeze just as I was pressing on the CPU there. Let's just see if that boots again. It did freeze there for a second. In fact, now it's not booting, is it? I think. Yeah, that's strange. Let's try and switch it off and on again. I'm not feeling any temperature issues on any of the ICs here. I'm just having a bit of a feel around. Everything sort of feels kind of normal. Weird how it was booting, now it's not. So I swapped Denise, still black screen, and then I thought let's just try swapping these CIAs around, which I've just done, and we've made some progress. So I don't know if you can see that, I'm testing with a Kickstart 1.2 ROM at the moment, and it's kind of staying on the dark grey screen. Look. So one of those CIAs is definitely suspect. I'm just going to pull them both off, and I'm going to replace them with two known working CIAs actually, because I think one of those is at least causing the instability and unreliability in the boot. It's not going to be affecting the video, I don't think, because I don't think they have anything to do with the C-Sync or H-Sync. Mind you, I don't think that's actually the problem either. It's like we've got a voltage issue somewhere on the video output side. I'm thinking the hybrid is the actual thing with the problem with the display. Actually, could be wrong. It's just a guess at this stage. But anyway, let's rest the CIAs out, and let me, as I say, I'm going to put two good ones in. So just the same. So maybe it's not the CIAs. Hang on. No, it isn't just the same. So I think the CIAs, one of the CIAs is part of the problem there, but I'm saying but. I'm not really sure. Hang on. There's certainly multiple issues going on with this board. It isn't just one thing. Switch it off again. I'm just having a hard time understanding why it wouldn't be very bright. Unless it was the hybrid. I mean, the other thing I should do here is just measure voltages. Let's do that. Before I do anything else, I'm going to measure voltages, because you know what? The symptoms we're seeing there, we could have something pulling a voltage low, actually. 5 volts might be dropping, or some other 12 volts or something. So I've got the meter in shot there for just measure between a ground on the board. You can't see, I've got to use one of the tabs down there where the screws go. And we'll just measure these pins here. 2.6 volts, that's not right, I don't think. -5, +5, -12, +12, maybe the 2.6 is right. What are these blue ones? Those are grounds, aren't they, the blue ones? Yellow, +5. So yeah, other than that one there at 2.6 volts, which you might be right, that might be the tick or something, I can't quite remember now. I think the voltages are okay. So I tried reseating Gary, that didn't make any difference. Let's reseat Agnes. Now this looks like this has been scratched already and chipped, so you know, oh, yeah, someone's broken the socket broke? No, the socket's not broke. This has been chipped before, so I'm anticipating this could be quite hard to get the Agnes to come out here. Yeah, see look, the corners have been chipped off, so there's nothing to grip onto. Does that make sense? Now the problem with this is it's been broken before. You see, look, it's not gripping. It's not gripping at all. The corners of the chip here are sheared off, so I might have no choice. I wonder if there's any holes on the underside on this one. Yeah, there's 2 holes there. I'm going to try and push it out from the underside carefully, one side and then the other. And then the other. Worst case is we have to fit a new socket. I'm hoping not. Yeah, so you can see some soldering's been going on in there actually. One of the 2 of the pins looks silverish. And on that side as well. I don't know, maybe it's just got a bad socket. All 4 sides kind of look like they've got little bits of silver there. Anyway, let's just see if we can inspect the chip here. Yeah, look, the corners on that are totally mangled. Can you see they've been chipped off? Might just try another 8372. We'll reseat it first and see what difference that makes, but I mean, to be fair, that socket's alright, it makes a nice tight fit there, so I don't think the socket needs replacing. Let me just show you what I found here. If I measure there, look at that, 1.5 volts, 1.5 volts, those are the 245s that form the DAC for the video output. And if I measure anything around here, you know, any TTL logic, 5 volts. 5 volts. So the supply rails are getting to the main logic, but these two chips here are only getting 1.5 volts. This is why it's outputting no video, and the video's all crazy. So I'm thinking a capacitor or something, but then why would the logic have 5 volts? Was that brown wire? Let's just check that. Is that why that has dropped? Let's just check that. Now that's showing 2.6 volts. I don't know how these are powered, but ultimately that is what is wrong. Maybe a resistor feeds them or something, and the resistor's burnt out or something around here. There's something going on that means these are not getting 5 volts on the VCC pin. So I removed this cap here. You know, I've been inspecting around here, but let me just show you. If I put the meter there, you can just about see that. This should be 1.2 ohms. Nothing, nada. That resistor's the issue. I know that's the problem, because if you measure from here to, say, I don't know, the VCC pin, sure, this is, I think, where the VCC is derived from, or in parts, I don't know. So it's a bit strange how that resistor has just gone open circuit. Maybe something got shorted on the video connector or something on the bus thing here at some point. Maybe there's another fault that's caused it. But I think that's the issue. I'm going to go see if I've got a 1.2 ohm resistor, and we'll just replace that. Well, I've sorted the video issue out. It was indeed that 1 ohm resistor. It's not 1.2, it's 1 ohm. But if I try and reboot this, it's not doing anything, it's frozen there, you can see. It's taken me ages to get that to come up. I mean, it seems to be booting now, I think. Yeah, look, we've just got a normal error there, a guru error. This could just be corrosion around the CPU socket, I don't know. It's strange how it's having to warm up here. I had some interesting issues running diagram where the video is flickering in and out of different colours, like, you can see that's frozen, I think. Oh no, hang on. Oh, did you see we had one little movement, then it froze? And if I do a keyboard reset, oh, in fact I can't do a keyboard reset on this because I'm using a 500 keyboard. Yeah, this is why I can't do a keyboard reset. This is the adapter I made in the first A2000 repair I did. I forget which one it was, part 2 I think. You can see I did heat shrink the thing here, but I used a little bit of a Vero board and stuck the pin header on there, like that. Pierced little holes through the heat shrink, you know, as I slid the heat shrink on, and then shrunk it. So I drew a little black line there for ground. Ground goes to green. So, just carefully plug it on. Yeah, that's how I'm testing the thing here with the keyboard. But the result is you don't have the reset signal going across. It's done differently on a 2000 keyboard. They do something to the data line, I think, or the clock line. I forget which. So it's really strange how it's kind of like partially working now. I mean, I've not fitted that resistor completely in place yet, and it's not using the right size. I've got 1.6 ohm at the moment, it's the only size I could find. But I'll order a 1 ohm resistor for that. At least that's some of the issues dealt with here. I mean, you can see that looked like it reset there. What seems to be happening when it's not working is if I probe the data bus and the rest bus, there's nothing. It's just, it stays static, which is really odd. But it has come out of reset when that happens. Like if I probe the reset pin now, I'll find it's gone high. 1, 2, 3, 4. In fact, the data bus is pulsing here. Well, some of the data bus, which suggests it's waiting for something. Yeah, it's come out of reset. I just don't understand what's making it hang. So I fixed it after work. I'll show you at weekend what I did. So what did I do to fix this? I'm not sure if I covered, but it was totally unstable. And in fact, after it had just sort of warmed up for a few minutes, it stopped working, and nothing would get it back on again. You know, I'd be reseating the CPU, reseating the Agnes, reseating the CIAs, just pressing things down, I don't know, and then eventually suddenly start working again, and then it would stop working. You know, it'd only work for a few seconds. So I cleaned off all of the black marks from around here. There was some really crusty, sort of like heavily carbonised, like burn marks. You know, it's like melted plastic and something that had melted. I don't know what it was. All around here and around the slot. And then I also cleaned up the CPU pins again for about the 5th time, and cleaned up the socket again with some vinegar, left it for about 10 minutes, you know, and then cleaned it with IPA again, cleaned it with vinegar again, cleaned it with IPA again, and then just reassembled it all, and it worked perfectly. It's worked every single time since, and I'll just show you. Again, it's been going on for an hour, about an hour-ish roughly, maybe a bit longer than that, maybe an hour and a half. 253 passes, no problems at all. Previously with this, when it was glitching, you could get into here occasionally and start the test and everything would be okay. It would pass for maybe 7 or 8 or 9 cycles, and then it would freeze, the system would crash, you'd get an exception come up there. So I think we've turned a corner. So we've dealt with the video issue, we've got stability. The only issue with this board now is Zorro cards are not, well, Zorro card, I don't have any of this to test on hand at the moment, is not working. So if I switch it off and carefully bring a Zorro card into the slot here, sorry, not there, that's the co-processor slot there, but if we just press this in, and this is an awful card, I'm going to be doing a review on this, it really is quite possibly the worst one of these cards for any system I've ever had, because the PCB needs shaving down. Can you see how hard that was to get in there? And it's even harder to get out because they've not shaved the ends of the PCB. It's like, it's rock solid. You could lift the whole board up like that with that now. That's in there so firmly. But anyway, that isn't the issue. I do know if I test this on my Rev 4 board, it still works. So there's not a fault with this. But if I turn it on now, and it's the same no matter which slot you put it in, it's consistent. I've cleaned the card up. Yellow screen. So yellow screen indicates some sort of hardware error, you know, a hardware fault. So I'm thinking, it's, you know, there's those 245s there. There's 74 ALS 245s. Now the difference between an ALS and an LS, the LS stands for low power Schottky. The ALS is advanced low power Schottky. And I think the difference between them is the ALS is faster and it can sink more current. So I'm guessing because you've got interface cards plugged into this, you know, plural, not just one. That's why they've gone with the ALS. I think it's not just about the speed, but it's about the being able to sink more current. You've got multiple things there connected up to it. There could be a very slight overlaps on some of the signals and things as it's transitioning, you know, reading between the different cards and the different slots there. So I'm guessing that's perhaps why they've gone with the ALS. Post a little bit more down below if you know more about that, but I'm guessing that's why. And the high speed again, because you've got some of the slots further away than you know, others. So I guess speed is an important thing. You know, it's an interface, isn't it? You've got interface stuff going through there. Now those chips don't feel particularly hot. I would say there's 6 of them, which you can see here. I did inspect. Sorry, the other thing I did to try and get it stable is I resoldered the. You see the wires here? I actually reflowed those, and that might be the answer because the board is warped. This whole area here is floating. It's warped up. It's separated. It's delaminated when someone's heated that. So my theory was, and the reason why I reflowed those is it may be that the wire on the top here has come away from the through hole plating in the middle because of the delamination. So yeah, sorry, I forgot to mention that. That might be why it's now working and it wasn't before. It was super hard to get it working because I don't think it was all just about a dirty slot here, and I don't think it was just the little carbonised bits of stuff around there. Anyway, so the next thing I'm going to do, I think, is I'm just going to try piggybacking one at a time these chips here to see if I can get past this yellow screen, just in case one of these is not passing, you know, in one direction, perhaps one, you know, connection. So I want to show you what I've discovered here. I think I am going to socket up these chips around here, maybe all 6 of them actually, but I think that the fault is this one, and the reason being is if I power it on, let me just try it, you won't see it. If I power it on without that chip piggybacked, we'll get the yellow screen, yeah? And if I piggyback this, we don't get the critical, you know, yellow, something critical has occurred, it can't handle it, it doesn't know what to do. You actually get the red screen. Watch, there you go, defective, and it's not defective. So I think what's happening here is that is faulty. So that's the one I'm going to remove first. We'll socket that up. So the complication with this is we need to remove this blooming thing here, don't we? I might just try that first, actually. I'm not really sure the best way to go about this. It's a bit, this is my first time removing something like this, where I'm removing a chip and there's a resistor like that there. It's not going to be easy, I don't think. So we'll just we'll see if we can use the desolder station. Yeah, you see, this is going to be the problem. It's like there's going to be a lot of thermal mass there, and how do you get rid of the solder without bending the blooming resistor pack or the legs? I could use hot air. The danger is, obviously someone's used hot air here before, but they've used way too much for too long. But with the delamination that's previously occurred, some further damage could occur. I'm not really sure the best way to go about this. I think I'm going to use hot air, actually. I'm going to use hot air. I'll use it super carefully. We'll get rid of that resistor array first. Then I'll desolder the solder from underneath the chip, and then we'll free it up with a bit of hot air. Like always, I've changed my mind. Let's remove the solder from here first, then we'll use hot air to free everything up. Because we may as well, once we've done the resistor pack, the chip will be almost at temperature to slide it out anyway, probably. Certainly on one side. I hope we don't lose any pads doing this, because this has been damaged previously from too much heat. You can see it's brown, it's like charred the board here a little bit. So it wouldn't surprise me if we lose a pad or 10. Yeah, they're not freeing up very well, these, and I guess it's because of the damage and the resistor pack. We might find we need to do the other one as well. That red screen there, we might get a red screen after we replace this. That might be the next thing, and then that'll just be, we'll have made a bit of progress, but we'll just have something else to deal with. It might be the one next to it, but this one here. So here we go. I removed it. The solder on that side came off super easy. It's just this side here where, you're going to get some of the solder there because of that blooming resistor array. The way I've seen these done before is the resistor array is on top of the chip and the pins are bent down the side of it. I might do that, actually. But we can test it. We can test it without that resistor array on to start with. It's going to work probably without the resistor array on there. I would imagine for accelerators and things like that, or if you've got multiple Zorro cards in here, or specific Zorro cards that may need those pull downs. I smell burning already. I don't like the smell of that. To be able to smell it burning so easily after just starting heating here. And you never know, that resistor array might be faulty. I haven't measured anything there, but we can do that as part and parcel of just removing this. Hopefully I've got some 3K3 resistor arrays if I need to replace it. I mean, in theory, when we get this up to temperature, we should be able to just pull the blooming resistor array off. Yeah, there we go, look. It's starting to come off, I think. Yep, that's that. Let's just lob that somewhere else. It's a real mess down there. It's really charred and stuff again. Now, do you see how easy that came off? And we haven't got any more warping. I mean, it was a bit warped here already as it is down there. But it's not charred. The round here is not charred. So yeah, someone's just used way too much heat over there. So I don't like working in this area of the board just because it's such a mess. It seriously is. I do wonder if this chip had been replaced before, because the solder points on it just look weird. I mean, that one there as well, but that just could be as a consequence of the hot air that was used originally when this was damaged. I don't know. Maybe they got reflowed at some point. So whilst that didn't make a difference, I thought let's just do this one anyway, because there was a difference obviously in behaviour when we piggybacked this one. And the good news is, it's working. It's fine. It's picked up that RAM expansion there, and it says it's working. So that's fantastic news. The next thing I'm going to do, I'm going to try and run this with the Terrible Fire. Now, I did this yesterday. The Terrible Fire accelerator works on here, but I'd just like to try it on this board which is completely unmodified 6.2 in conjunction with that RAM board. I suspect the RAM board will then say it's faulty. Now the interesting thing is it's not showing the RAM board as faulty, which is terribly confusing actually, because this makes me think this RAM board can coexist with the TF534, although it doesn't. Is it booting? I'm not sure that it's booting. No, look, it's crashed, doesn't it? It's not booted. So there is an incompatibility between the two. The two don't seem to like to coexist. Yeah, there you go, look, defective. That's exactly what I was seeing on the other board. So that's good news. It's just confirmed what you've not seen yet. I'll show you in a future video. So booted Workbench 2 there. And you can see we've got 1 meg of graphics mem and is that 800k? Oh no, it's not. There's an extra digit, 7 digits there. 8 meg of the mem. So it is fixed. That's it now. So this board, I think, is 100%. I'm waiting for the resistor. So we've still got that floating 1.6 ohm resistor there to fix the video just for the moment. Soldered over the old one. But I have ordered some new 1 ohm quarter watt resistors. I'll fit that when that comes in a minute. But other than that, it's just to clean up. Actually, this board is now 100%. And testing with sys test there, just to be sure, you can see there's 9 meg in total, 1 meg chip, 8 meg fast. And it's gone around once, it's on the set and pass now, no problems. So I think the Zorro issue on this board is resolved. There is still something needs doing actually in that area. There are 3 of the little capacitors I'll show you. They're totally incinerated. So yeah, I would swap those out as well. I did plan on socketing up the 2 chips around the where the board had started to bubble up originally, but you know what, I'm not going to disturb that because the solder points underneath look good, the chips work okay, but I will swap out the 3 caps. Now the interesting thing is I'm pretty sure these had been swapped out previously. The reason I know that is these chips here that look like factory, the pins are splayed out, you know, they're bent right out sideways. These ones here are not, they were straight down. They weren't bent at all. So I think someone swapped these 3 out. They were different makes because that's a Signetics there. Obviously I've got a Motorola and a Texas Instruments there now, I think. I've got some other ones, I'll perhaps swap them out in a minute. But yeah, so it was a bit warped up here. Can you see that? There's a bit of a bubble there. You couldn't see it because the resistor packs were over here. So that's not something I've done. But what I would say is once you've had the delamination started like this, if you heat things nearby, like if I was to move this one now, the delamination will spread kind of around here just because this is already bubbled up and there's a lot of tension there pushing certain ways because it's rippled. Does that make sense? So in theory this might have got worse just from me using a little bit hot air just to free these chips up here. But you do have to be careful if you're using hot air on these boards. As I talked about in part 1, just as I was removing one of the little the buffer chips over there, I could hear some little clicks and squeaks and things. I wasn't actually moving anything or putting any pressure on anything. That to me is a clue that the board is starting to delaminate. So you just got to use like I say, preheat the wider area for, I don't know, 60 seconds, 2 minutes, you know, I don't know, 200 degrees. Obviously cover things like this up with caps and tape. This is the problem here, this is why this is all melted. Foil, you need some foil, stick some aluminium foil, fold it up 2 or 3 layers so it comes out to about this distance here, and caps and tape over it, and then this wouldn't have been melted here. And here as well. I managed to chip out, can you see, the little holes there were all melted over, and I managed to reform that so that it's okay there. It's still a little bit rough on the edge. I can use that sharp knife on that in a minute just to smooth that off. But yeah, so those are the things you need to think about. Anyway, I'm going to get these 3 off now and swap them out. I've got the ones that I took off an old A500 board. They're going to be 220 or 330 these, I think. I'll just check. But yeah, they're going to be fine. The ones I've got are going to be fine for replacing those 3 bypass caps. Yeah, they're coming off pretty easy. I'll show you on macro in a minute. I'll show you the most burnt one, but they're just absolutely incinerated. I'd be amazed if those still work correctly, actually. So the next one is here. The legs are bent over, which yeah, causes you pain. Just trying to, you've got to get the solder station on at an angle like that, kind of wobble it over a little bit, wobble it around, you can hear it moving. Sorry, the camera's wobbling while I'm doing that, I've just noticed. This one over here might absorb a bit more heat. It did on the other cap, this side. This is the positive side, I think. There you go, solder removed. And on this side there, you can see it's just hanging through. You can just pull that out. Might need to use the pliers because it's at a funny angle there. Come on. There we go. So again, That should be yellow. That should be yellow like these. See this one here? Look how yellow that is. The underneath is, but on top it's just absolutely melted. So just testing the 245s, the old ones. One of them works okay, which I've just put to the side. I'll stick that back in one of the sockets in a minute. This is the one I think is faulty. Should give us a yellow screen if it is. Yeah, there we go. So it definitely was one of those. The reason I wanted to do things like that is, in my own mind, I'm thinking, was it definitely the chip, or was it a bad solder point? I mean, unlikely, it looked well soldered. Or was it the resistor pack short in somewhere, or one of the pins not joined properly? But yeah, we've proven conclusively now that the 245 was the issue. So I'll leave the replacement 245 in the other slot, and I'll put the original one, which was in the other position, into this position. And as you'll see, this one is working. Yeah, booting. So if we go into memory, there we go, 9 meg, and just leave that going around for a bit. So the next thing I need to do is remove the bungee resistor here and the one there. I'm just going to remove the one from underneath because that one will just come off with it because it's soldered on there. But I'll desolder the points from underneath and we'll get a new 1 ohm resistor on there. So it's these two diagonally opposite points here. I'm just going to add a bit more solder to that actually, a bit of fresh solder with flux. Yeah, it's unblocked a little bit. Managed to pull that through with some heat, I think. Or just give it longer to for the heat to, you know, pass through. Yeah, they're pretty thick traces on the other side, so it's just going to need some additional time, I think. Because this is, remember, it's the VCC rail here. Yeah, that one's not too bad. Let's just try that one again. Yeah, again, not so bad. There we go. There we go, that's our resistor in place. So I'll just cut the legs down and clean up with some IPA. So the next thing I'm going to do whilst I'm here is just swap out the four 470s. There's 3 here and 1 up here. So after final reassembly there and a test, everything is working okay. You can see we swapped the cap there. These 3 caps here, and obviously the resistor there, you can see at the back, just mounted just like the original one was. And I marked the top of those caps with a red dot and then just marked this up to say it was repaired, partial recap 2019. So the final thing I've done on this particular repair, and I did it off camera because you've seen it all before, I just removed the chip here, desoldered the pins underneath just using the desolder pump, you know, solder sucker. I didn't even use the desoldering station. And I guess you can use better control of heat that way, well I find you can, and I've got a smaller tip on my iron than I have on the desolder pump, on the desolder station. So yeah, I removed the chip, freed it up with hot air, no additional damage from the heat or anything like that. You know, it didn't, even though this is bubbled up. And if anything, can you see it's almost like gone back? It's like the bubble, what was really super bubbled has actually gone back a bit just from me heating that and removing the old chip. So, but anyway, it looks better. It's got a socket on there. The reason I socketed this up is, A, there's a lot of damage around there. It was really dirty, lots of bits of black plastic melted onto the pins and things that I hadn't seen, that you couldn't even see until you got the chip off. It was around the pin, you know, the holes that the pins go through. It was like black melted, well, not even plastic, it's like carbonised plastic that just disintegrated totally. So I cleaned all that up, put a socket on, and I've replaced the 74F245 with the 74ALS245, the same as this one, because that's what this should have here. But as I described earlier, as a consequence of heating this with hot air a second time to remove these ICs, bear in mind I'm using the right temperature. Whoever did that work originally has used, I don't know, a wallpaper stripper or something, because you'd need an awful lot of heat to do the damage that's been done to this. The socket here, I just, you know, smoothed it down a little bit on the edge. Now I could replace that. I've got some of these sockets actually. I've got both a spare one of this here and a number of these spare brand new Foxconn connectors, so I could swap those out at some point, but like this side here, it was just a little bit there, can you see? And I just smoothed it down with a file, so it looks okay. And with regards to the stability and Zorro issues, the stability, yeah, I think it was these vias here actually, because as soon as I reflowed those vias, you know, put nice little beads of solder on there, it started working. And there's a reason for that. You've got a top layer of the board and you've got a bottom layer of the board. And when you board, and obviously you've got a through hole that sort of sits in between the two, you know, so you've got a pad on the top here, a pad on the bottom here, and they're joined up by the via. the through-hole plating inside there. And as soon as you delaminate the board, it can warp like that. So that through-hole in the middle, it's only, you know, it's got a thickness that joins from this side to this side here like this. As soon as it delaminates, it can pull away. So the pad at the top can actually be separated from the through-hole leading to the wire on the other side, if that makes sense. And I don't think it had completely gone open circuit there on one of the pins. It was just like borderline, barely touching. It was only when I reflowed these that it started working. I mean, I did mention I cleaned around the CPU here. That's, you know, obviously par for the course. You should do that. I haven't replaced the audio caps. I will do that later off camera. I've just done it on so many boards. There's just no point in showing it you, but trust me, I will do it. And incidentally, while we're here talking about the audio coupling caps here, you know, swapping those out for some audiophile Muse high quality bipolar caps, check out the videos just been uploaded by Jan Beta. The start of this video was done just over a month ago, I think, but this final sort of showing you the board here, this is literally just as I'm uploading the video. And Jan Beta's just done a video and he gave me a shout out. Actually, I've got to thank him for that. That's much appreciated. So yeah, if you like anything to do with repairing old systems and things, if you're not already subscribed, I'm pretty sure you will be, check out Jan Beta's channel. I'll stick a link down below to his channel. So our video problem was caused by this resistor here that feeds the 5 volts to these ICs here. You know, it gone open circuit. I'm not entirely sure what's caused that. One of the things you've got to realise is it was 1 ohm. I think earlier on when I first spotted it, I thought it was 1.2, but it's not. It's 1 ohm, a 1 ohm resistor. And whenever you got super low resistors like that, those are prone to shorting out. You know, you get a little bit of too much current drawn because it's such a low resistance. It can dissipate a fair bit of power in the form of heat. So it doesn't take much for a 1 ohm resistor to burn out. If you had, say, a 470k resistor there, there's going to be a lot less chance of a resistor of that size popping. So yeah, that's something to consider. You know, 1 ohm resistors and things like that, they can pop out, you know, they can pop. Similarly, that's one of the reasons why inductors can sometimes fail. You know, you get like little ferrite beads and things like that. Those can go open circuit. We haven't seen it much on my channel. I've talked about it a little bit. I think when I looked at my Sega 32X, actually, it was one of the things I remembered from when I was back in the day, because I had 1 or 2 32Xs came in with that were dead, just showing a black screen, and measured around, spent a while checking things, and actually found an open circuit ferrite bead. And I've found that sort of fault on other systems in the past. So, you know, it's because it's so low resistance. So, I mean, that's not why it fails ultimately. Sometimes it'll just be a bit too much current drawn. So, for example, I don't know, something could have been shorted on the video connector back here. Maybe the 5 volts gets fed through to there, or maybe the 5 volt gets fed through to here. Maybe a fault was developed on a video card that was plugged into this, and that ultimately caused that to fail. There's all sorts of ways of looking at that. If it was much worse corroded, I would have replaced the socket. But you know what? It does seem to have been quite contained here. You can see, you know, there's just a little bit of, the silk screen worn off around there. That's the sort of ideal scenario where you can just get away with cleaning. And the final thing to point out is, you know, I left in, and I could have removed it, you know, because it makes me look like an absolute idiot. It seriously does. You saw what happened trying to remove this, the way that the PLCC extractor was not gripping and it was slipping. It didn't matter how I held the PLCC extractor, whether I squeezed a lot before trying to pull, it just kept sliding off. And this is why we get these scratches here. But the reason that happened was a consequence of that, you know, similar thing happening in the past, I think, where the corners have been chipped off on the very edges there. So that is now proving very difficult to remove. I mean, ultimately, the other thing I'd point out, you saw that the pieces of plastic inside that socket that go, you know, on the underside here were a bit broken. Someone has actually shoved something through here to remove it in the past that way. So I could replace that socket, but you know what? It's making a good connection. That wasn't the source of our problems. So coming back to the Zorro stuff, I'll show you a page of the schematics in a minute, just so it's crystal clear as to why I targeted these chips here when the Zorro card wasn't working. But ultimately, I knew from previous experience of looking at the schematics that the 2 chips that are in this position here with the resistor packs on, these isolate, buffer the data bus from the Zorro side. So the 245s here, they're bus transceivers. You can enable or disable them and change the direction that data travels from, the A side to the B side. So these, obviously there's 2 of them. You've got 8 connections running through each. This is your 16-bit data bus. This is what is used, these 2 chips are used to buffer the data bus access to the Zorro slots, wherever those are, over here I think. So this was an obvious candidate. I think that some of the address lines and things might go through some of these here and some of the control signals from the CPU as well, but this is all Zorro related. I'm not sure if putting the resistor packs on the bottom side was a good idea or not. I'll leave you to decide. Personally, I think it is, because it's easier to maintain. It means just chips on here are not hindered in any kind of way with those, and you can just remove them and replace them, and you've still got the resistor arrays there. But obviously the downside is somebody looking at this when it's installed in a case could go, oh, it's not got the resistor arrays on it. Now, yeah, you could measure, and you know what, I've been doing that with any of the mods I've been doing, is measuring, you know, if it says stick a resistor array on, you know, this side here, sorry, it's this side here, isn't it, the left side, stick a resistor array on there, so you've got ground down here, and then each of the connections have got that resistor there. Well, you can just measure, put your meter on resistance mode, measure from that pin to each of the other pins, and if you see 3.3k, you know there's a resistor array on there. So it's not that much of a problem, but someone could make the mistake and think there's no resistor arrays and solder on the top side here and double up. So you can't quite see, but again, this is a Rev 6.2. It's identical revision to the board that I'm using myself in my own beloved Amiga 2000 here. So I'd like to say thanks to Tom for sending this. It's absolutely brilliant. This has been assisting me testing all sorts of different Amiga upgrade boards and things, as you'll see in some of the future videos. I'd also like to thank Stefan again, because you see this ESD bag here, it's just the right size for an A2000 board. He sent me a few of these, and my spare A2000 boards are now sat in these, which is fantastic. They've got a nice little protective home away from static electricity. I do hope you found the video interesting. I'd like to thank you all for watching. Thank my patrons as well, because without my Patreon support at the moment, having lost my job, I wouldn't be able to continue doing this channel, but it has just been such a lifesaver, the support I've had from everybody. People offering to send various things like this for me to, you know, to use for spares and to keep and to repair or to sell or whatever. It's really made a huge difference. You know, I have managed to secure a part-time role working for a friend, home-based. So my money has taken a massive drop, but you know what, with the Patreon support, my channel can keep going. I'm out of the danger zone kind of thing in terms of securing some financial security there. So I mean, you know, I don't need to move house and don't need to sell off my collection just yet. It means that things can keep going. So thank you very much, everybody, for your support. I'll catch you in the next video.